Hey everyone, welcome to the Neo4j live stream. My name is Will, and today we are talking about the Neo4j GraphQL library. This is a follow-up to a previous stream that we did last week, which was covering the 3.0 release of the Neo4j GraphQL library. There were a few features that I wanted to demonstrate that we didn't get a chance to. So that's going to be the focus of this stream, is looking at 3 features specifically that I think are really powerful in the Neo4j GraphQL library. That is database introspection. So previously we were looking at driving the data model of the database using GraphQL type definitions. But what if we have an existing Neo4j database? Can we just generate a GraphQL API without writing type definitions or any data fetching code? That's what the database inspector, Introspector rather, allows us to do. And the ability to drive database indexes with GraphQL type definitions. So we'll look at creating uniqueness constraints and also full text indexes. And then the third thing I want to look at is some of the generated aggregations that are available when we build a GraphQL API with the Neo4j GraphQL library. So those are the 3 things we're going to look at today as kind of a follow-up from where we left off last time. So question from Abdul, will this stream include something about authentication? No, this stream will not be covering authentication or authorization. I can point you to some good resources for that, but we will not cover that today. Today we're going to focus on the database introspector, database indexes, and aggregations. Yeah, great question. Great. So yeah, thanks everyone for joining. As you have questions, please drop them in the chat. We'll be sure to answer any questions that folks have. With that, let's share my screen here. Okay. So as I mentioned, we're picking up from where we left off last time. On last week's stream, we were looking at the 3.0 release of the Ifj GraphQL library, and we were also just kind of talking about, in general, what is the Ifj GraphQL library and some general features there. And then we talked about some of the new things in the 3.0 release. So I won't go over that in too much detail. There's a great write-up here from Daryl that covers a lot of that information. So drop the link to that blog post in the chat. So where did we leave off last time? I guess before we jump into that, let's just really quickly talk about what is the Ifj GraphQL library and why do we use it? If you're just dropping in, so to set some context for us, I guess. So the Ifj GraphQL library is a JavaScript package that's designed for building Node.js GraphQL APIs backed by Neo4j. So GraphQL is a technology for building APIs. So we're talking about that layer that sits between your client application, if that's like a mobile app or a React app, whatever your GraphQL client application is. The API sits between your client and the database. You don't want to expose your database directly to the end user applications. Often you want this API layer so that you can add things like authorization rules, custom logic, caching, these kind of things at the API layer. And so the Ifj GraphQL library is a package for building Node.js GraphQL APIs that basically allows us to take GraphQL type definitions that define the data available in the API, the data that we want to work with, and it uses that to drive both the Neo4j database and also our GraphQL API. So while it is a JavaScript library, there's often little JavaScript that you're actually writing when you're building these. Most of the code, most of the configuration and things that you're writing are really GraphQL type definitions using the GraphQL schema definition language, or SDL. So I'll drop a link to this page. This does a good job of explaining what the Neo4j GraphQL library is, how to use it, some of the features that we talked a lot about last time. Another good resource that I'll just link now is the documentation. So Abdul was asking earlier about authentication and authorization. I'll drop a link to this section in the documentation. There's also a blog post somewhere. I think maybe it's in here. Let's see if I can find this really quick. Is this covered? No, not linked in this one. I'll find it later. There's a blog post that Dan on the engineering team wrote that covers a lot of the powerful authorization rules that you can create. So the way that authorization works in the Neo4j GraphQL library is we define these authorization rules with this auth schema directive. So we kind of annotate our, let's look at an example, authorization. Where is a good one. So there are a few different types of rules that we can create in the GraphQL schema that map to the claims of a JSON web token. So JWT is the standard token that is used for authorization. So as long as you can generate a JWT, and you can use this with something like Auth0, or most identity providers have some JWT support. But basically, what you're doing is defining rules declaratively with this schema directive, sort of annotating your types to create rules that say like only the author of a blog post can edit it, these sorts of things. And then at query time, those rules are enforced by the generated database query. Anyway, that is not the subject of what we're going to talk about today, but just wanted to mention that and share that link to the docs. Hopefully that is at least a helpful starting point. Cool. So where did we leave off last time? Here's where we left off last time. So I've pushed the code up to GitHub. So let me go ahead and drop a link to that in the chat. So all the code from last time is on GitHub. There's also a link to the video recording from last week, which is part 1, and then part 2, which is what we're watching now. This just links to the YouTube page. So let's see where we left off last time. So over here, I have, let's look at package.json. So I have a Node.js project. Let's zoom in. Hopefully that's big enough. Maybe that's too big. Yeah. So we've installed a few dependencies, the Ifj GraphQL Library, the Introspector package, which we're going to use today, Apollo Server, which allows us to build GraphQL APIs. We can use the Ifj GraphQL Library with really any JavaScript GraphQL implementation. Apollo Server is I like to use. It's quite nice and straightforward. Then we're using the latest GraphQL release. This is GraphQL JS, or the reference implementation that most JavaScript GraphQL servers use, and then the Neo4j JavaScript driver, which we use to make a connection to the database. Yeah, Abdul, so it sounds like you're getting some authorization error with Apollo Server Micro. Are you using that with Next.js, I'm guessing, with Micro? Cannot fetch. Yeah, maybe maybe you could post some details on the community site. So that's community.neo4j.com. Maybe just post some code examples so we can try to figure out what's going on there. Yeah, so there's, make sure that you have your authorization header in the correct format. So it says a bearer token, so it should say bearer and then a space and then the token, something like that. But yeah, just create a post on the community site there that I linked, and we will try to figure that out. Okay, so these are the dependencies that we installed for our project. Let's take a look at index.js here. So we were working with Neo4j Aura. So you can see I have my Aura credentials just pasted in here. Here's the database in Aura. So Neo4j Aura, if you're not familiar, is Neo4j's cloud service, which I will drop a link to here. So Aura is nice for lots of reasons, but one is this free tier. So I can spin up a Neo4j instance in Neo4j Aura DB free that I don't have to put a credit card in. It's free. These databases don't go away. So it's great for development and testing for sort of side projects. That's what I like to use it for. So I created this database last time. And we started off with a blank database, and then we defined some GraphQL type definitions, and we created some data. So we're working with data about movies and actors, super simple because we were just starting from scratch. Let's look at our code to see where we ended up. So we're pulling in some of our dependencies like the Ifj GraphQL Library, Apollo server, and so on. Then we are reading our type defs from this schema.graphql file. Let's look at that. So these GraphQL type definitions, these define a couple of things. They define the data model for our GraphQL API, but also for the database. So there's kind of a couple different ways to approach sort of creating your GraphQL API with Neo4j. One is to define your data model using GraphQL type definitions, and then that drives the data model for the database. And a good way to do that is to start with arrows. Let's see. Yeah, here's one. So arrows, which is just arrows.app. If you have seen this before, this is a graph diagramming tool that allows us to sort of create our data model use visually as we're going through this visual data modeling exercise. I often like to think of the questions that I have ahead of time for my business requirements and sort of think of a traversal through the graph as I'm creating it and sort of ask the question, okay, is this going to answer the questions that I have of the data? But one thing that's nice about arrows is we can export our, zoom in a bit here, there we go. We can export our type definitions or export our data model as images, as Cipher to create, as JSON, but we can also generate GraphQL type definitions. So this is a nice way to generate our GraphQL type definitions from a visual tool. We don't have to kind of type them out. We can just sort of draw the diagram as we want to create it and then export to GraphQL type defs. Okay, so we created a movie type and an actor type, and used a relationship field to show how they're connected in our type defs. So we're just reading our type defs from that file as a string. We create a Ifj JavaScript driver instance that is connected to our Aura database. Then we pass the type definitions and the driver to the Ifj GraphQL library, create a new instance of that. And then we can generate a schema from that. So this is the process that's going to take those type definitions, add entry points, so that's the query and mutation type in GraphQL terms, add entry points for all of the create, read, update, and delete operations for each type. And then we pass that off to Apollo server, and we didn't have to write any data fetching code. That's all generated for us by the Ifj GraphQL library. And then we took a look at writing some GraphQL mutations to, which I might still have open in this tab. I have the query open for it. But we basically created this data. So we added Keanu Reeves and a couple of movies that he's connected to. Okay, so that's sort of one approach, is to start with your type definitions and use that to drive the data model. We also talked about adding custom logic with the Cipher directive, which is really powerful. So now we have this recommended field, which is showing us movies we may be interested in based on a traversal through the graph. So Cipher directive is super powerful for adding custom logic as expressed with Cipher in our GraphQL APIs. But what about if we already have an existing Neo4j database and we want to create a GraphQL API that exposes that data, but we don't really want to go through the process of hand typing out our type definitions. We have the database, can we just generate these? And that's where the Introspector comes in. So I'm gonna go back to the docs and take a look at the Introspector page. Drop a link to that in the chat. So the Introspector, the basic idea here is we can point this to a existing Neo4j database. It will inspect the data that exists in the database, and we can use that to generate GraphQL type definitions that can then be used with the Neo4j GraphQL library. So we'll add the relationship directives here to encode the relationship type and direction and figure out the types of all the fields, how they're connected, and so on. And then we can either, in our case, we're going to write this to the schema.graphql file. But we could also do this each time when we spin up the API. So the other example here is just pass those type definitions off to the Ifj GraphQL library and spin up an API. So we don't even have to look at them, I guess. Let's see how we can do this to write to a file, because what we're going to do is generate our type definitions from an existing database, and then we're going to tweak those a bit, right? We might want to add some custom logic, or in our case, we're going to add some database indexes. So to do that, we need an existing Neo4j database. I'm going to use a database that I have set up that has data from the New York Times API. I think every day I grab the most shared articles and I think the most viewed, or like the most emailed articles. So basically the like 20 or 25, whatever it is, most popular articles of each day. And I have this kind of running in a cron job in the background. So this is what the data model looks like. We have articles. Articles are about a person a geo region or an organization. Then they have a topic, and articles have photos as well. So if we look at, let's just pick some topics here. Here's exercise. Here are all the articles about exercise. I'm going to do a style reset so we can see the captions there. And you can see the details we have for each article. So here's one about walking boosts the immune system. Great, that sounds good. We have abstract, just kind of like a description, the author, the date it was published, the URL. If I double click on this, we can see the other nodes that it is connected to. So we can see the other topics like memory, longevity. We can see here's the photo connected with this one. So you can get a sense of the this one, yeah. So you can see the other topics. It has Alzheimer's, age, elderly, memory, brain. So you can get a sense of how the article graph here is built. So this is a good data set. It's been running for a while. So let's see how many article nodes we have in it. So that's just matching on all articles. So there's almost 7,000 articles in it. So I think I've had it running for a few months, grabbing 20 or 25 articles each day. Okay, cool. So the Introspector is going to allow us to generate some type definitions. And what we'll do is overwrite the type definitions that we have in this schema.graphql file, and then start up a new GraphQL API, and we'll see if we can query some of this news data. So I have taken, this is basically the code from the docs here, which again, I'll push up to GitHub when we're done here. But basically, what we're doing is importing the Introspector, a Neo4j driver instance, and then we're going to write to the file system. So we need the FS package. We create a driver instance, so a connection to a Neo4j Aura instance. Here, we're reading from environment variables. I think I've set these. I guess we'll find out in a minute. I think I've set those so that they're pointing to the Neo4j Aura instance that has this news article data. And then we are creating a session. So a session is kind of like, you think of a session as kind of like a unit of work with the Neo4j JavaScript driver. In this case, we're creating a read-only session. So, hey, I just need to read some data. And then we wrap this in a async function because the to GraphQL type defs is a async function. So once that comes back, that's going to go out to the database, inspect the data that exists there, generate our GraphQL type definitions, and then we're going to write to this schema.graphql file, and then we'll be done. So let's give that a run. So node introspect. And this kind of depends on the size of the database. This one just took a few seconds. If you have a large database, it may take a little bit longer, but this is something that you're typically only going to run maybe once, or maybe just at the beginning of when you're spinning up your GraphQL API. So it's not something that has to run several times. So let's take a look at schema.graphql. So our movie type defs are overwritten. Let's get a little more screen real estate here. So the convention that is used by the Introspector and by the Neo4j GraphQL library is that node labels, so every node in Neo4j has a label, doesn't have to, but that's typically the conventions. We have at least one label for our nodes. Those map to types in GraphQL. And then properties, those become fields in GraphQL, and relationships become relationship fields. So for the node properties that become fields, we just grab the name of the property and introspect what type it is. So we have abstract, that is a string. Looks like we have a lot of string properties, maybe not so many numeric properties here. And then for the relationship fields, you can see there's kind of a convention here for naming the field. So we use the camel case version of the relationship type. So if we look at our data model here, let's look at this one. So for example, article has photo. So here's the article, it has an outgoing has photo relationship to the photo node. The convention in Neo4j with the property graph model is to use all uppercase with these underscores for spaces. Not sure what the name, that's not snake case. What's it called when you use the underscores for spaces? There's a name for that. Anyway, that's the convention with the property graph model in Neo4j. So it would be kind of weird to just use that for the field name in GraphQL, because the convention in GraphQL is to use camel case for field names. So that's one thing that's nice about the relationship directive. It allows us to keep the right conventions. We can keep the naming convention for Neo4j in the property graph, and then we can keep the convention for our GraphQL API. Mario says that is constant case. Great, thanks, Mario. Okay, so then the name takes the name of the relationship plus the name of the other type. So in some cases, this works out. I guess it depends on how we name our relationships in Neo4j. This is kind of awkward. Becomes has topics. So if we had just named this has in the database, article has topics, this would be has topics, which would make a lot more sense. And you can see there's some pluralization as well. But this is really just a starting point. The generated type definitions are really just a starting point. We can edit these as we see fit. But let's fire this up. So now if I go back to index.js, and so these are my hard-coded credentials that everyone can hack into my my Aura-free instance we were using last time. So let's read from our environment variables. This is going to be Neo4j URI, I think. And this one is going to be process env Neo4j password. And let's run index.js. And let's see if that works. It says it's ready at localhost 4000. So we'll jump over to Apollo Sandbox, which allows us to query our API. And we can look at the documentation. I'll try to zoom in as much as is reasonable here. So if we look at our fields on, this is the query type, you can see we have entry points for articles, we have arguments for filtering, and then we have the fields that we expect. So we can start querying this right away. Let's write a query to maybe find the most recent articles. So we'll say articles, and that's too much zoom. This is as much zoom as we can do. So articles and maybe the, what do we have? A title and the published date and the URL. So I don't want to bring back all articles. So we're going to add a where filter. And I want to inline my variables. Going to zoom out one more to get the inline variables. Okay, there we go. So let's inline our variables. So the input is going to be, no, I don't want to where, I just want to sort. So it's going to be under options. Let's inline variables so you can see it here. And the options are going to be the sort order. So the convention that we get for the sorting in the Neo4j GraphQL library is we get this sort direction input. So we want to sort by published field in descending order. And then also, let's do a limit 20, 15. And we'll run that. So this is giving us the 15 most recent articles, which are from the 28th, which is what, yesterday? So I guess we didn't pick up today's articles yet. So for whatever reason, my cron job has not run yet. Okay. Oh, we didn't see the generated cipher. Let's go back, and I'm going to restart the server, but this time I'm going to set the debug environment variable. So if we set this debug environment variable, we can control the debug logging that's logged when we execute queries. So now if I run this query again, yeah, there we go. I can see the generated cipher query. So we ran this GraphQL query, which says find the 15 most recent articles, give me title, published, URL. That was translated into this cipher statement that executed against the database. And then as we add fields, so maybe we want the has topic topics, so the name of each topic. And you can see our generated cipher query now includes that traversal to the has topic nodes. Okay, cool. So that is the Introspector, which is super useful for generating GraphQL type definitions from an existing Neo4j database. It's basically just a great way if we want to expose a GraphQL API on top of a database we're working with. We want to expose that data for an application or share that data somehow. It's super simple. We don't really have to think much about how to construct the GraphQL API, how to write data fetching code. That's all handled by the Ifj GraphQL Library. We get some somewhat sensible defaults. We can tweak these as needed. And one of the things that we're going to tweak in this is adding indexes. So let's find this section in the documentation, indexes and constraints. Yes. I'll drop a link to that in the chat. And again, feel free to ask any questions in the chat that you have as they come up. So there are a few different kinds of indexes in Neo4j. We don't use indexes with a graph database the same way that you might use an index in a relational database. So we typically use an index to find the starting point of a traversal. We do not use an index to traverse the graph. So in a relational database, you have indexes on your foreign key fields to see where two tables or two sets overlap. That's an index-backed operation. That starts to slow down as your tables get really large, because indexes, the performance of indexes depend on the overall size of the data, right? In a graph database like Neo4j, we don't use indexes at traversal time to follow a relationship from one node to another. We're just sort of like chasing pointers in that case, if you think of it that way. But we do use indexes to find the starting point for a traversal. So oftentimes this will be looking up like an ID field, or maybe like, in this case, if I have, I don't know, an article. In this case, the database is so small, I have 7,000 articles. So an index is not really going to help me performance-wise, but maybe if I had the URL, I guess that's kind of the only unique field here. If we had the URL for an article, we could look that up and just jump right to that article node and then traverse the graph. Or if we have the name of the organization and we have an index on that, it can be more efficient to find that starting point rather than scanning through all of the nodes in the database. If we have a large database, again, this database is not super huge, so we're not going to see any performance difference. So that's how we use indexes. We can also create constraints, so uniqueness constraints, which allow us to start to impose some sense of schema, some constraints on the database. So for example, let's look at we don't really have any ID fields. We could treat, say like URL, we could treat as a unique field. Like we should never have any article nodes in the database that have the same URL. Or for organization, that would be name in our case. So we should never have two organizations with the same name. That's a data integrity problem. So that's a database constraint, specifically a uniqueness constraint. We can also create things like property existence constraints, things like that. But that those constraints are backed by an index. So an index is created in the database that it helps us to enforce that rule. This is why this logic is often explained together in the documentation, indexes and constraints, because a constraint needs to have an index to back it. And then there's also full text indexes, which we'll talk about in a minute. But the way that we can create database indexes and constraints for our GraphQL API is through the use of directives. Now, we could create these using Cypher. There's some Cypher commands that we would typically use for creating indexes in the database. This is sort of like a convenience feature so that we can ensure that the indexes and constraints that we've defined in our type definitions are consistent with what's existing in the database before we bring our GraphQL API online. So that's why we can define these indexes and constraints in the type definitions. So the way we do that for a uniqueness constraint, let's start there, is to mark a field with this unique schema directive. Maybe too much zoomed in. There we go. So let's try this on organization. That's a good one. So organization name should be unique. Basically all of these. So name for person should be unique, same for topic. And you would typically have an ID field or like a UUID or something as you're creating entities. There we go. So I've defined these now in the GraphQL type definitions. If we go to our database in Neo4j browser, I can type :schema, and this is going to show me any indexes and constraints that exist in the database. And it looks like there's this kind of built-in one for lookup, and then there are no constraints. If I go back to index.js, there's a line here that I'm going to uncomment. And this is calling assert indexes and constraints on our Neo schema object and passing create true for the options. So what this is doing is at startup time, so this only runs when our GraphQL API is first launched. So this is not running for every query, but basically it's checking the indexes and constraints that I've defined in my GraphQL type definitions, comparing those to the indexes and constraints that exist in the database, and if any need to be created or updated, it's doing that before starting our GraphQL API. So let's save that and restart our GraphQL API. And you can see we get a lot more output. So we can see here, we're about to execute Cypher. So we're going to fetch the indexes, and then it realizes, hey, we do not have a uniqueness constraint on geo, on organization, on person. So all of those uniqueness constraints that we defined in our GraphQL type definitions need to be created, and it ran those before starting our GraphQL API. So now, if I run schema again, we'll see that now I have a bunch of indexes, and those indexes are there to support the uniqueness constraints on geo, organization, person, and topic. So now I have those uniqueness constraints. I will not be able to create duplicate nodes. So I won't be able to create another organization node with the same name property. Let's test out. So Microsoft, let's try to create a duplicate Microsoft Corp node just to verify that our uniqueness constraint actually works at the GraphQL layer. So I'm going to go to create a GraphQL mutation. Trying to find the right amount of zoom here. I know it can be kind of hard to see. Okay, hopefully that's good. So we'll say mutation, and we want to create an organization. Let's get our inline variables. I just think that's easier to read. Okay, so let's create some organizations, and we're going to set the name to Microsoft Corp, and then return the organizations that we created. So what should happen? We should get an error, right? We should get some message that says, hey, your constraints, constraint validation failed. Yep, that's what we expect because we have a uniqueness constraint on the name property of organization, and we already have a Microsoft node. So that's great. So that's going to help us enforce that logic. Mario says, in the future, Introspection will automatically create indexes and constraints from GraphQL into the type defs, or do you need to introspect the database and create it manually? Yeah, so so that's not currently, I don't think, currently a feature of the Introspector. Let's take a look in the docs. So I guess the question is, if we had indexes in the database already, if we already had these uniqueness constraints, would the Introspector add the unique directive? or indexes if we've created them. And I don't think so. I think that is on the to-do list. So currency is currently relationships, nodes for, right. So if we have, so the node directive allows us to basically change the one-to-one mapping. So in this case, it's saying if we have a character in our node label that's not valid for GraphQL, GraphQL has a more narrow, I think it's alphanumeric only for types, whereas it's a bit more broad for, and it can't begin with a space. I think it's a bit more broad for the property graph. Then we'll add the correct label. And then if we have multiple node labels, we'll add additional labels. And you can also use this for read only. So I don't think we currently supports adding the indexes inferred that exist in the database. I'm pretty sure there's I've seen a card for that because that's something useful for sure. Yeah, good question. Okay, so we tried to do something invalid. The constraint helped us out here, so that's working as we expect. Another kind of index that we can use are full text indexes, and this is helpful for oftentimes like search functionality in an application. And full text will allow us to create an index on one or more fields or properties, node properties in the database. And this is really nice for something like article here, where I have a couple of different fields that contain information about the article. So I have like the title field, and then I have the abstract field. So if I'm searching for articles and I want to find, I don't know, articles about Ukraine or something like that, whatever the topic of the day is, I can index both the title and the what did I say, abstract field into a single index. So I can do a single search operation to match anything contained in both of those fields. I can also do things like fuzzy matching. If I have some slight misspelling, I can still match. I can do case insensitive matching with a full text index, all these kinds of things. So Neo4j supports full text indexes through Lucene. Lucene is a super powerful text engine. So I can create these full text indexes in the database. And there's also functionality to leverage that in the Neo4j GraphQL library. Basically, I define a full text index in my type definitions, and then I have additional query fields to search using those indexes. So that's what we're going to do next. Let's create a full text index on the article type. So let's look at the docs here. So create the full text directive on the type. So this is going to be on the article type. So we'll say full text indexes takes an array. So we want one, let's call this just, I don't know, article index. And then we need to specify the fields. So like I said, one thing that's really nice about full text indexes is I can combine multiple fields. So I want title and I want abstract. And then I need a curly brace and a bracket. Yeah, there we go. Cool. So now I've added this full text index. So it's saying create this index. If it doesn't exist, call it article index. and I want to combine the title and abstract fields into this index. So we'll save that, and I'm going to restart my GraphQL API to pick up those changes. You can see it does the check for finding the indexes, and it goes through the unique indexes. There's a if not exists, so included in that cipher command. So these indexes already exist, they won't be created. And that's handled by the database. And then we create the index for our full text index. Great. Server's ready on localhost 4000. So now let's go to Apollo Sandbox, take a look at our query fields. And now I see an additional field, or an additional argument rather, on the articles field, which is this full text argument, which takes a phrase and a score equal. So let's see how we use that. So we said articles, and let's get, I don't know, the title and abstract and the URL for the article. And then we want to use the full text field, or the full text argument rather. So we'll say full text, and then I'm going to switch to inline variables so we can get autocomplete on that. And we need to specify that we want the article index here. Actually, let's look at the docs. So at query time, we have a key for the name of the index. So we called ours article index, and then we pass a phrase and then optionally a score. We'll talk about the score in a second. So let's jump back here. So full text, we have the article index and a phrase, and let's search for articles about Ukraine. So we should now be finding, let's make this a bit bigger. Cool, thanks. Tooney says, constraint index is complex. Yeah, yeah, it takes a bit, I think, to reason about how you use indexes. Specifically, I mean, with databases in general and how that can impact things like search and whatnot, but also, yeah, that key point of the way we use indexes in a graph database versus like a relational database is a bit different. So yeah, important concept for sure. Okay, so what this has done now is we're able to search for articles about Ukraine. You can see we're getting a lot where you can see most of these have Ukraine in the title. Is there one where we're picking it up from the abstract that's not in the title? Probably not. That seems like a common word to include. Yeah, here we go. So here's one. So this is about US escalating sanctions. Ukraine doesn't appear in the title, but does appear in the abstract. So we're able to search both of those fields with one query operation. So you can imagine this is in our application, we have this like a search box somewhere, like what articles are you searching for, that kind of thing. What if I have a typo? So if I leave off the E in Ukraine, well, I'm not going to get anything. But what's nice is that this is a full text index, so it exposes Lucene query functionality. We can add a tilde, which is syntax in Lucene for fuzzy matching. So I think by default, it will do like a, what is the right term? Levenshtein distance, basically like substitution. So I think maybe by like 2 characters or something like that is the default. So fuzzy match where 2 characters could be changed. So now I'm going to find my Ukraine articles. We can do lots of other things. Like I think we can do like Ukraine or Russia if I want to match on both of those terms. So kind of like what you would expect in like a Google search bar, something like that. I think the docs links to the Lucene, Lucene full text query language, which is quite powerful. So what's nice is that we can leverage any of that syntax in our full text arguments as we are searching. Cool. So full text indexes are super useful for that sort of search functionality. In this case, searching for news articles. You can kind of imagine how we would leverage that as kind of the backing functionality for a search box if we were building a web application or a mobile app with this news data. Okay, so we talked about the introspector. We've talked now about indexes and constraints, including full text indexes. The last thing I want to look at are aggregations in the docs. This is in the query section in the docs. Yeah, here we go. Aggregations. So drop a link to that section in the docs. So aggregations are really useful when we want some like summary information about some data that we have selected. So for example, and I think this is kind of the initial place where you might see this, and there may be a example in the docs, no, maybe not, but in pagination. So there's a couple of options for using pagination with GraphQL in general, but also with the Ifj GraphQL library. So one is offset pagination, where I'm using like skip limit. So give me the first 10, then for the next page, give me 10, but skip 10, right? So I get the next page. And then there's cursor-based pagination, where I'm using opaque cursors to specifically define what pages I'm interested in. Now, if I think of how I'm going to render this in my UI, well, oftentimes I need to know how many pages there are going to be, so I can put down on the bottom of the page, like, you know, page 1, 2, 3, 4, whatever, up to the number of the maximum. And so I need to get a count of the total number of the things, right? So that's an example of an aggregation. So let's say, for example, that I wanted to show a bunch of articles. So let's write the articles query where I'm going to show, I don't know, title and abstract and URL again. And let's inline variables here. And I want to sort by published in descending order and, I don't know, limit 10. So something like this, where I need to paginate in chunks of 10, well, I need to know how many total articles there are. And so that's where I can add count. So here I've added the articles aggregate, and then there are a bunch of fields on here. We'll take a look at those in a minute, but one of those is count. So if we run that, we can see there are, okay, 6,836 articles. So now I can compute the number of pages that I need to have if I'm paginating through articles. What's neat about this is that the same filters apply here. So if I'm filtering, I don't know, let's say maybe where we're going to filter for where the title contains Ukraine, we can use that same filter on the articles aggregate and on the articles field. So now we're paginating all of the articles about Ukraine, and there's 77 articles. So if I'm doing 10 at a time, that's going to be 8 pages. So on my client application, I can compute the total count for the number of pages I need. So that's kind of a basic case where I would use aggregations. There are lots of other really interesting cases as well. Like, for example, maybe I want to know some other summary information, such as maybe who's written the most number of articles, or who has the, what article is highest ranked, this sort of thing. So there are other, go back to the docs here, there are other aggregation fields that are generated. So we looked at count, we looked at using the generated filters with the count. We can search for longest string fields in this case. And then we can also do aggregations across relationships, which is quite nice. And then any of the numeric fields will have the numeric aggregations like min, max, average, sum, and those sorts of things. So let's look at an example for that. And then I think we will be about out of time. So do we have anything interesting we could do an aggregation on? Let's look at article. So we have, I guess we don't really have any numeric fields. We can do maybe the longest. So here's, what's the longest title in the database, and we can also look at the shortest. Red COVID. And again, we can use the same filters with these. So here's the shortest title, article about Ukraine, and the longest. If we had any numeric fields, we could also do numeric summaries like maximum, minimum, average, those kinds of things as well. But that is a good introduction to aggregations. Count, I think, for pagination is kind of like the canonical example that you think of, but there's all kinds of other like data visualization opportunities as well for using aggregations. Cool. So we're about out of time, and those are the 3 issues that I wanted to cover. So the code that we left off with from last time is in this GitHub repo. I will push our changes from today up as soon as we're done here. That's a good place to find the code, and then also the recordings as well. So thanks everyone for joining. Be sure to follow us on Twitch or YouTube or wherever you like to watch these streams to find these in the future. You can also find these on neo4j.com/events. We usually publish the things we are planning, live streams, and also in-person events as well. We're just kicking off a training series. So we're gonna do these are 2 or 3 hour live trainings, one each week for the next 4 or 5 weeks. So first one, what is that, tomorrow, which is the intro. And then we will have one on Bloom. And then we will have Graph Data Science. And then I'm doing one on GraphQL, where we'll take a look at full stack GraphQL. So we're going to see how we can build a GraphQL API using the Neo4j GraphQL Library, but then also with Next.js to build a full stack application and deploy that using Vercel and Neo4j Aura. So that should be an interesting one. That's on the 16th. If you're interested, be sure to check that out. Cool. So thanks everyone for joining, and hope everyone is staying safe out there, and we'll see you next time. Cheers.